I've started a con. Man, it's just like really fucking zoomed in. So here we go. Hey, so what you got going on? You've got a bunch of enders then, or?
Yeah. So what's happening is, so I got 4 enders right here. Okay. And so this is the last one we built, and I didn't even build it. My sons built it for me.
Mhm.
You know, I was kind of busy doing whatever. So they're like, 15. So I think they grudgingly built it. But what I'm noticing here is that the one that was here was really messing up a lot. Finally, this filament is helping out a little bit more. The Ziltech or whatever filament is doing a little bit better. The Solutech, which I used to use a long time ago, it was horrible. It was not doing well at all. But one thing, the problem here with this thing is that it doesn't happen all the time. But the noise, I hear this right here, a lot of noise, like tack, 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 tack. Like it's not, yeah, it's that dull, like it's like trying to suck it in there. And this G code was made by, was it Brandon? I think he made this G code, and he made it run in an hour and 10 minutes for 2 of them.
Okay, so is that same G code running on all 4 of your enders right there now?
It is. The others are doing fine. And then once in a while, once the noise starts to make right here, right? Okay, I'll be right there. Once the noise makes here, if I depress this button here, I don't know if you can see that. Can you see that?
Yeah.
When I do this, it stops the noise.
Yeah, sure.
And then it continues again. I'm wondering, what other settings could there be causing this to happen, where at the end of the day, if you look closely, like for example, okay, like the pink one, okay, let me do a really side-by-side comparison. Okay,
just a real quick question about the history of these 4 machines. Do they all have the same nozzle?
They do. They're
stock. They're all the same nozzle size?
Yeah.
I'm unfamiliar with the generations of the ender exactly. They didn't have like different nozzles in different generations.
They're all 0.4. They're all bought at the same time. I'm pretty sure. You're thinking they may. They're all Pro, Ender 3 Pro.
Yeah.
I don't know if there's a way for me to check. Okay. So this is what's happening here, right? Do you see how the pink is very thin compared to the gray?
A bit frozen.
Right?
Okay, now it's better. Frozen? It's not frozen anymore. Okay. I'm sorry, I'm seeing what you're saying. What is it?
Gray, the gray is a lot thicker than the pink.
Yeah.
Mostly, the pink is a lot thinner, right? Meaning, at times, I don't know if it's not extruding enough. First of all, what's causing that clicking sound?
Right.
Is it what's caused? Do you know what causes that sound?
Sure, exactly. So when the drive mechanism is gripping that filament and pushing it through, that's tuned very precisely to do exactly as much power as necessary to do that. And it seems to be working on your other machines. But this other machine has some kind of resistance to that in some way. So it becomes all of a sudden, hey, that's not enough to push the filament, and the motor, it just skips a little bit, right? So it's not able to push. That sound, is it failing to push for a second?
Okay, that's what it sounds like. Because when I hold the filament with my hand, right, it feels like it's like goes in, it's not going in as smoothly, right? It's like backing up a little bit and then going in again. It's like it's attempting.
Right.
So then I try to tighten. I try to tighten this screw right here. I don't know if that makes. Can you see that?
Yes, zoom in there. That's important. Thank you. Where's this? What are we looking at?
This thing right here. I try to tighten that screw.
Yes.
And this didn't do anything. Is that the screw I should tighten, you think?
Okay, so what that screw does is each of your extruders, right? the filament, imagine going between my hands like this. It has like this wheel here that's a bearing,
Right.
or your drive gear, sorry. And then this other mechanism. Now this other mechanism clamps the filament against the drive gear, right?
Right.
It's like a bearing. Usually it's like attached like to a lever, like a spring or whatever. But you can adjust essentially how much pressure that thing is putting against it. So if it's too loose, then yeah, certainly sometimes it's just going to be like, that's not sufficient to like clamp it and push it through. So yeah, you want to make sure that all of those assemblies, you want to look at the one that has the least amount of that sound happening, and you want all of them to be like that one. You want them all to be adjusted to the same degree that the one that's the quietest is. What's the one that works the best? That's the quietest.
So I see. Okay. So let me get a flashlight really quick here.
Mm-hmm. Excuse me, my cat has decided he's gonna join us here.
No problem. So I don't know what you can see because I cannot see the screen. Can you see this right here?
Yes.
Okay, so there is no distance between this black part and this part right here.
Yeah.
Whereas over here, I see that there's like a big old gap right here.
Oh my goodness. Yeah. Right. So that thing is no, but more importantly, look at the compression of the spring. Right. So this one is like kind of whatever, and this one is like dialed way in, right? Is that what I'm seeing?
Should I be screwing that a certain direction, obviously, or is there some kind of a nut there that's missing?
I can't say without being able to look precisely.
You know what? I feel like there is some kind of maybe just the screw itself.
Yeah, well,
I realized you're right. There is such a there's like such a gap right there, you know? Whereas mine doesn't have any of that gap. Okay, this one has a gap, big old gap, big old gap, big old gap, and no gap at all.
Okay, yeah. So basically what we want to do is find the one that's working the best.
Yeah.
And adjust them all to match that configuration.
So I'm wondering if I need to, just tighten clockwise or counterclockwise. I'm not sure.
Well, which one do you know is the best one? I don't know if we have identified that yet. Do we know which one?
What? Actually, all of them are okay except this one.
Well, so the one that's making all that kicking noise obviously is not the one that we emulated.
Right.
So some other one. Which one is the best one?
This is the problem. This is the problem right here.
What's that?
This machine is a problem. This is the one that makes all the noise. But right now it's not making the noise. But so I'm gonna tighten that later. But let me ask you this right here, okay?
Mm-hmm.
Let's see how this is doing. Okay. Okay, this one, I don't know if you can see. My goodness. This got torn up so badly. Okay?
Yeah.
I mean, I just got this thing. So sometimes the problem is when I'm like leveling the bed, on this corner it's fine, on this corner it's fine. The middle is super tight. What does that mean? Does it work?
Perhaps. It's not. I mean, what is this thing? Is this a pad? Can I see one?
It is a pad, yes.
Do you have a spare one that you can show me what it looks like off the machine?
Not right now because they're all running.
Yeah.
But I ordered some new pads. And I mean, I only had this pad for 2 weeks. But what happens is sometimes when I try to like undo this, take off these things, right?
Yeah.
Like look at this, right? You see that black mark right there?
Mm-hmm.
How's my resolution here?
Kind of. Yeah, I can kind of see what you're.
Yeah.
Yeah, I do.
So it's like, there's a black mark right there, which is from the residue from. It's so hard to remove it. Not so hard. I can remove it, but in the removing process, it's taking out chunks of that surface. Does that mean it's too close to the bed? Do you think?
It could be. It could be. Yeah. What's your first layer line look like? How smushed down is it?
Right. So what I'm noticing here, right? If you look at this,
Mm-hmm.
like on the left side is darker, and okay, on if you look, I don't know if you can see it, but you could tell that this part is like there's less filament there.
Yeah.
Can you see that? I don't know if you can see the difference there. Like
Yeah.
over here, it's like all missing. It's missing over here.
Sure.
Like random parts are missing. You know what I'm saying?
Yeah.
What
So
does that mean?
tell me about how familiar are you with the bed leveling procedure of the printer?
I mean, I know how to level like on the corners, right?
Right.
Okay. And I don't. This one doesn't have an automatic leveler, obviously. Okay.
Okay.
So I need to like manually level it myself. So
Right.
I set to home, and then I click on I disable the steppers,
Yeah.
right? And I get a piece of paper, and it's kind of like, I mean, I've been doing this for a long time, but
Right.
my familiarity was with Monoprice Maker Select,
Yeah.
but they were giving me such a hard time. How do you
these-
like those, by the way? What do you use personally?
I have experience with a lot of things. A lot of Airwolf 3D products. I worked with Airwolf 3D for a while.
Okay.
I built.
Those are expensive, aren't they?
They can be. Yeah, they invest in their own slicer software. They make their own slicer software, not just profiles for Simplify or something like that. So it's pretty neat. But just remind me again real quick. The Enders, are they 3 or 4 point leveling beds?
I think, but they're not. They're 4 points. Yeah, 4 points.
They're 4 points. Okay. Yeah. So the thing with a 4 point leveling, with respect, different than a 3 point. With 3 points, you can pretty much usually just do it one time because 3 points define a plane. But when you have a 4th point, you have like all this extra, this moves that kind of stuff going on.
Right.
And to properly level a 4 point bed, what's actually required is you go to a point here, you do an adjustment, right? Okay, whatever that is. You go to this next point, you do that adjustment, whatever it is. And then when you get to a point where, hey, I need no adjustment here, that's 1, okay? If you get to point number 2 and it's still no adjustment, that's 2. If you get to point number 3, you need adjustment, that's 0 again. You got to adjust it. You're done when you have 4 in a row that need no adjustment.
I see.
You can't just do a couple and then you have to do it around a bunch of times sometimes, like even 4 or 5,
Yeah.
And then like that's the best way to do that. And then to keep it level, for sure, what you want to do is things like take advantage of your ZN stop trigger if you want to adjust your offset distance, right? Don't try to use the corners to like shimmy your bed up a little bit to close a Z offset, right? You know what I'm talking about?
No, I missed that. What was that again?
So essentially, if you have really thick layers, right?
Yeah.
The distance from the bed to the nozzle at the beginning of the print, that's going to be kind of far. If you have really thin layers, that distance is going to be thinner, right? Right. So sometimes, and also if you want to say like make that distance a little narrower on purpose so that the first layer gets smushed down onto the bed and sticks better, you can do that. So that's all talking about just adjusting your Z offset. And sometimes folks think, hey, I can adjust my Z offset by moving the corners of my bed all up the same amount. And it's like, come on, like don't do that. Like it's you want it to be properly parallel, with the XY motion of the head and all that. So you don't want to just try to close a Z offset by re-leveling the bed. You always want to use your Z end stop trigger to do that if you need to.
How do you do that Z end stop trigger? What does that mean?
So basically when your bed homes, right? Yeah. It has a little screw usually that goes click, and that screw touches and clicks a little button. Okay. Mm-hmm. So if the screw is, see the end of my finger is a screw. If it's higher up like this, then that bed comes up higher and then clicks, and makes a shorter Z end stop. But if it comes up only to here, then that's not as far. You can adjust the initial offset distance of your nozzle to your bed this way with a Z end stop trigger that you adjust up or down.
And where do you want that? Shouldn't that be enough for a paper to go through?
Sure. Yeah, you could do that. I mean, the slicer settings that you specify are also going to affect this as well. So ideally what you want is for all of your machines to have exactly the same, physical parameters, so that they print the same G code in the same way, right? So that means the screw that adjusts your tension on the extruder mechanism up there, it should all be the exact same on the, and you should copy the one that's doing it the best, right? And also your bed, you should make sure that they're all, you know, properly level, because it's important. If it's too close, then it's going to be like backed up and not come out at all, right? If it's too far, it's not going to stick.
So the fact that this entire structure, okay, this thing right here is so much thinner, okay, than this other one from a different one from the same G code, could be that it's not pumping out enough filament, correct? That's probably the reason why.
Well, when you say thinner, you're talking about a Z height is different?
Yeah, the Z height.
Really?
Yeah. It's
Can I see them side by side, please?
Right here.
Can I see them side by side?
Let me get the best possible lighting here.
Yeah.
Okay. Let's see.
So I can kind of see the thick. Yeah, the pink one is way thinner than the gray one.
Yeah, way thinner. And I'm talking, it's not. It's more than 10%. It's more like 20% thinner.
Okay.
That's a lot.
So another physical difference between your kits. There may be something different with your Z coupling in each one of them. Do you know what the Z coupling is?
So I think it's the things back, the two metal rotating things. Is that what they are?
Yeah, that they grip the base of the threaded rod for the Z, and they couple it to the motor shaft of the stepper motor. So it's a little like collar, essentially, at the base of the threaded rod.
There's two of them, right? There's two of them.
Are there two Z threaded rods?
I think, are there two of them?
Am I looking at a machine with two Z thread rods?
Let's see.
Is that what I see? No? Is it one? Where's...
I mean, let me hold on. Let me get some light down there.
I think it's one. I think an Ender has one. Just this one on the left, right? The threaded rod. No, not the pulley on, not that motor. We're talking about the threaded rod. Oh, you're trying to look at the base of the Z. Are we
talking about...
Do you see that upright threaded rod?
Are we talking about this thing down here?
Perhaps. Is that what's at the base of the threaded rod?
Yeah.
Okay, yeah. So there may be some difference with the threaded rod coupling from machine to machine if they're all built from kits.
Yeah.
So like one thing you want to be mindful of is the way those couplings work is the top half of it grips into the threaded rod like this.
Okay.
And then there's a tightening screw that holds that in place. So that tightening screw should be tight. And then there's the bottom of the coupling like this, it grips the motor shaft, and it also has a tightening screw. So you want to make sure both of those tightening screws are tight, that both those things grip on both ends like that.
So they should be, can I move one up, one down, or is it just make them tight? That's it.
Just make them tight. Because essentially what's not happening, it sounds like, is one of them may be loose, and every time one that's properly tight turns, it goes the correct amount up. But the other one that's not so tight, every time it turns, it only goes like 80% of the way up because it's kind of not like gripping it, right?
I see. Okay, got it.
So those are set screws on the Z threaded rod coupling.
Right. So check that one. Another question is this. Now this thing right here, right? This, what is this called? The extruder unit, right?
So basically, we like to differentiate extruder and hot end. Hot end is the thing with the hot barrel there, and then extruder is the mechanism of the motor that grips and moves the filament. So this is a boating.
What is this whole unit called?
That's the hot end. And
this whole thing is the hot end?
It's that's a hot end right there.
Okay.
Well, there's a carriage, right? There's a belt. There's all that.
Right. So my question is this. Okay, when I am physically moving this left and right in order to level with a piece of paper, right? I feel this thing moving up and down, and I'm like it's kind of like disturbing because it's kind of moving up and down as I'm moving it around, and I'm like,
there you go, bro. You just confirmed my diagnosis with the Z coupling, because you shouldn't be able to do that. It should be firmly gripped to the Z motor, and if you can lift it up and down, that means it's not coupled on there tight enough.
You mean the fact that this goes up and down means that back here is not tight?
Yeah, it could easily be related to the this is the one with the that's thin, right?
Yeah.
Yeah, yeah, for sure. So that Z coupling is loose, and it doesn't step high enough with each Z increment, and it's loose so much on there that you're able to lift it and move it and feel it. And yeah, you're right. That's not right. It shouldn't be like that. So
What
there's
about
definitely
this? What about this belt right here? How tight should that be? Remember, earlier I had a major problem because it was not tight at all. So we fixed that problem. I watched the YouTube video. I put a little thing in there, like Allen wrench, and like stretched it. How tight should this belt be?
well again. You
They're
have
like
the benefit of having four. So I would
yeah.
say, what's the most successful one? What does that look like? Go ahead and emulate that.
Right. So it's this one. But my question is, there is no way for me to measure how tight something is except like how can it be too tight? Can it be too tight? Is that a problem?
It can be too tight. Yeah, that can be a problem. I mean, if you're really if you can find a long enough length that you can pluck, you can actually. I mean, you can kind of approximate the pitch. Maybe if you're, you know, savvy enough, I suppose. If you have a musical ear.
Uh-huh. So I don't know if you can see this, but you clearly tell that it's more pink on this side than this side and the middle. And so that's a bed leveling issue, I suppose. Or could it be the coupling too, though? Could it not? Could it
That could be a. So I would say, if you want to know for sure, what you got to do is you got to switch the plates on two printers. And if the problem follows the plate to the other printer, then hey, that plate is a misshapen plate, right?
I see.
But if it's the same, even with some other plate on there, then you're like, oh yeah, definitely my bed leveling is the variable here.
I see. So you just gotta move parts around.
Yeah, you have four. This is amazingly helpful.
Yeah. Okay, and I'm using like almost the same filament from every company. But have you noticed that the colors also vary? Or I guess, well, from the same company, should the colors matter?
I mean, colors, it's whatever. It's weird sometimes. I remember one time we had one company where all the yellow filament we got from them would we had like 5 machines clog up with the yellow filament with just yellow, and completely like different machines, different stuff, and it was bizarre. But like all the other color filaments, they were fine. So
I guess it could also mean that maybe sometimes some of those maybe have been old. Maybe that's definitely a factor, right?
Yeah, age can be a factor, but yeah, certain filament dyes are actually don't work so well.
Oh my gosh, it's like, man, 3D print. And then what do you use? Do you use Simplify 3D?
It depends what machine I'm working with. So basically, the slicer settings that you specify, it's obviously super important. It's even as important as like building your printer correctly, right?
Yeah.
Even if you build a printer, perfectly, if you specify crap slicer settings, you're going to get something that looks like garbage, and maybe you think your printer is broken when it's fine. Right. So like specifying the correct slicer settings is like a whole domain of things that it takes a lot of time. So I like to take advantage of pre-existing slicer settings whenever I can, and Simplify 3D does have lots of agreements with lots of printer companies where they've like worked with them and they have profiles in their software, and that's pretty good. Not all of them do, and sometimes they don't all have like the profiles as far back as you'd like for older models of whatever printer, or maybe they don't anymore recently, and the new one isn't in there or something like that. But certainly in every case where a printer company makes its own slicer software, you should always use that, like with Tier Time, the Up mini printers, they have this proprietary little slicer software, and it's fine. And then with Airwolf 3D, they had Apex. So with Apex, they update the defaults in it all the time for you, right? And then you update, the slicer software, and it comes with the most up-to-date settings for like all their advanced materials, the PC, the polycarbonate, right? So yeah, slicer settings are everything, and you can use Simplify 3D as long as you're not just like making up whatever settings. It's always good to start from somewhere, right?
Yeah.
Yeah, the enders have a lot of stuff in there.
So
for
have you
sure.
been printing these face shields as well? Are you
Yeah.
doing that or?
Yeah, I have.
What, what
I do 10 a day.
Yeah. So are you doing like um are you following the zero infill?
The
Or
zero infill.
they're recommending zero infill on these, right?
I haven't seen that. I've left my infill to defaults,
I see.
which I believe is like 20% or maybe 22.
I see. I see. So like something like have you like I've been printing this stuff, right? Okay.
Right. On the
So
smaller printers that can't print the face shields, right?
like, I'm using these little cutie thingies, right? And so
Neat.
yeah, I like that little cutie thingy. It's kind of like cute. It's a little cute thing. And so this one, I think I'm doing zero infill. I think, okay.
Mm-hmm.
And walls. Walls are like what I don't understand is what does it mean to have zero infill? That means what's the difference between walls and shells? Are they the same thing?
Yeah, walls and shells are the same thing. The term shell, technically, so a wall is a stack of shells, right, like this, to make like a skin up the Z like this.
Okay.
But a shell is that. A shell is also, though, a solid top layer. So a shell could be either this thing or a wall. But a wall is only a wall. A wall isn't a shell.
When you say like walls, you can go like 2, 3, 4, 5. What does that mean that has 4 or 5 walls? Like, are they next to each other?
They can be, yeah. So basically, your nozzle diameter, you said it was 0.4 on these. Is that true?
Yeah.
So the 0.4 thickness is the thickness of a single given drawn line of plastic, which also affects your tolerances, right, on an XY plane. So if you imagine you're drawing something with a pencil, right, but then you go over that pencil with a big fat Sharpie.
Yeah.
So the thickness of that Sharpie line is basically going to be like an encroachment on your tolerance. So like a thing that's a 5 millimeter hole with a 0.4 nozzle, that's going to be really like 4.6 on the inside and not 5, because you're going to get the thickness of that wall encroaching on the tolerance there, essentially.
If you have more walls, it's going to take longer to build. Yeah, correct?
Correct. Yeah.
So then, like, let's say if I say one wall, that will be less infill in a sense, or no?
Walls have nothing to do with the infill. So the infill is just that honeycomb or grid line structure between the walls on the inside.
The walls.
Yeah. So it's doing the perimeter lines, right?
Right.
And then it's doing this like hash or whatever on the inside, right?
I see.
So the density of that grid, that's the percentage infill. So a 10% infill is basically a given space like that, 10% filled with lines in it, you know?
I see. So this has zero infill. How come it's solid?
Well, that's because there's probably like so little inner volumes that like the inner wall, like these walls are just like edge to edge mostly. So it's like not really a problem.
So then I think we made this for like 3 walls or something. So that means when they designed this thing, okay, they designed it sort of solid, I suppose?
What's that?
When they designed this thing, they designed it kind of solid, didn't they? Already.
Yeah, sure.
So in a sense, that's why this could survive at zero infill. Okay. So whether this has 1 wall or 3 walls, is it going to matter in the strength of this or more filament?
Yeah, if you put more walls, it'll be stronger, sure. And it'll take longer to print.
But where would the walls even, what I don't understand is like, where would the walls go? Like, do they go built up or do they go to the side?
Yeah, it's like concentric. So it's like the profile of a cylinder, right, is just a circle. Right. So one wall is just a circle, and then a second wall is a circle inside that circle, and a third wall is a circle inside that circle.
Okay.
So the whole, profile of each layer is like that.
I see.
With the concentric walls.
When also, is it called wiping? What's the purpose of wiping?
Where would you see that?
It's something about, is wiping like when they start that, when they draw a line in the beginning, is that called wiping? I'm not sure. Yeah,
that could be, yeah, sure. That feature could be called wiping for sure. Like when it has the initial like purge line that it does at the beginning.
Uh-huh.
Uh-huh.
And what kind of temperature have you had for these things? I guess is it vary by printer and the speed, right? The temperature, right?
Yeah, everything is so in these instances where you have these profiles, what's
Yeah.
happened here is like there's been lots and lots of hours of people printing and trying this setting, tweaking it just one little, bit and trying it again and
Mm-hmm.
testing. So yeah, the temperature settings are pretty fine tuned in, and it's not generally a good idea to tweak with them, you know.
Mm-hmm.
You're just running ABS and PLA mostly, right? What do you PLA?
PLA. I mean, I heard ABS are kind of toxic. Is that right?
Well, ABS is pretty universal. I mean, it's used to make plumbing pipes and to Legos as well. And
But I heard when you're like making it and burning it, it's a little more toxic. Do you use ABS?
yeah, I use ABS. That machine behind me is bringing ABS right now.
And so they need higher temperature, correct?
Yeah, it prints at
PLA?
about 245.
Okay. But what about Petchy? What are your thoughts on Petchy?
Sure, that's a nice recycled material. That's the material you see that are like clear water bottles. That plastic is PETG.
Oh, I see. I see. And I heard they're a little difficult to work with. A little, I don't know.
No, it seems as reliable to me as ABS, and it's prints in similar temperatures and stuff. Yeah.
So you prefer ABS to PLA then?
Yeah, but that's only because of the bed surface upon which I print, which is a glass surface. I print on a glass surface bed with a material called Wolfbite, and the Wolfbite is a heat-activated glue. So when the bed is hot, the thing is glued down to the bed. And then when it becomes around like 90 degrees and it starts to cool and bow, the Wolfbite becomes no longer sticky. And as it like bows, it essentially peels itself off the bed. It doesn't bow a lot, but longer things will. But when it's pretty interesting to hear it. It like crackles as it releases. And then when it's done, you just poke it. It's not even attached to the bed at all. So I find that to be like a really handy feature. It also works with the polycarbonate material that I can print with at higher temperatures. But the PLA Wolfbite, I don't really like it that much. I don't use it. But when printing with PLA, I definitely prefer those surfaces that you got there that are that you put on there. For sure, I would say that probably like the best investment for you right now is to like get 3 or 4 more of those the platforms, right? Because what you want to do when you're doing high volume is you're going to take this one off, I'll put the other one on, go right away.
Right.
And then you can take the other one, you can take your time getting it off, whatever you need to.
Should you does it have you like can you just keep running these things all day long?
Yeah, for sure.
Like without breaks? Is it better to cool off a little bit in between prints or no? Just keep going.
You can just keep going. Yeah, it's fine.
And then what about like you should level the bed when it's warm, correct? Because it's the difference, isn't there? I noticed that when the bed is cold, it's like really tight, the paper won't move. And as the bed gets warmer, the paper slides easily. Because I guess the heat does something, doesn't it?
Well, you want to level it under the conditions that it's going to be operating at, right? So if there's heat, then give it the heat. Right. Ideally, you probably could level it with your hot end hot without the filament in it. So a thing you want to avoid is you want to avoid your printer's hot end being hot with filament in it and it's not moving through the hot end. You don't want it to ever just sit there hot idling, because what can happen is the filament conducts heat up its length and it can swell in the upper length and get stuck in the barrel. That's why you always see the filament design, right? You've seen the fan that's on the front of the hot end, right? Mm-hmm. And the hot end has this like section with all these like fins on it and stuff, right? A cooling heat sink. You probably have seen that.
Yeah,
right?
Heat sink, yeah.
So that's what's going on with there. That fan, it's important that fan always be operating so that you prevent this phenomenon called heat creep, the heat traveling up the length of the filament, because it's important that the upper length of it be cooled by this mechanism here. Keep cool and keep cool. But if you go too hot, you can heat creep. It can swell. It can get stuck in there.
Yes.
And if it's not moving, then definitely that's going to happen. So if you're just sitting around idling with a hot end, it could swell the filament and get stuck in there.
So then when leveling the bed, the PLA, the hot end should not be hot. But
you do want it to be hot, But if you take a while doing it, then you should probably not have filament in there while you do it.
I see. Okay.
And then
Got
to
it.
keep it properly level, certainly always take those build plates off. Never like jab at the printer to
Yeah.
try to get something
Yeah.
off it.
Yeah.
That's really bad.
Right.
And all the more reason to have extra plates.
Yeah, man, they're not cheap. I'm gonna go to, like, I'm destroying all of them. Oh
Oh
my
yeah.
God. It's only been like two. And I guess this is an unusual situation because normally I would do like one print a day, like that takes 26 hours, 36 hours or whatever. Now I'm doing like one print every hour and 10 minutes. And I'm just like destroying that bed right now.
Mm.
My goodness. So what do you do? You work at a brain builders?
Sure. Brainstorm is a education or contractor, and we have this like big old warehouse in Irvine where we accumulate all these STEM assets. Like there's a bunch of laptops, there's a bunch of robots.
Okay.
There's like over 400 laptops, and like all these kits are robots. We have all these 3D printers, and basically teachers around the schools, they don't have time to like fix a robot,
Yeah.
or like it would be nice if all their materials were completely like looked after. So we have like these craft kits. They have tapes and scissors and glues and markers that always work. There's no dead markers, and all the materials, they're all gone through and made sure to be stocked. And all the robots, I've done robot repair. I'm able to like switch robot motors in Dash robots, and I'm always making sure that the 3D printers work. So we print like, whole classes of 30, before lunch each day. So
Oh, so
like,
you actually go what? You help. So you guys are a consultant or
no, so
provider of equipment?
we collect all these assets, and then we have a bunch of instructors who they go to the site with the asset, they do the class. We've also developed the curriculum to do each of the classes, each of the content, right? There's a lot of IP in the form of all the curriculum that we have.
I
right?
see.
So we have a lot
Is
of
it
curriculum.
Brainstorm or Brain Builders?
Brainstorm. Brain Builders, I believe, is another company that has tried to start doing what we've done there, but they don't have the scale of the clients that we do. We have
Who are your
like
clients then?
we have a lot of elementary school clients all around the whole Orange County.
Are they public or private usually?
They're all public schools.
Oh, okay.
Yeah.
So your teachers then take these printers into the classroom?
No, we don't take the printers into the classroom. The 3D printing class, what it looks like is the kit that's involved. There's a kit of 25 computers, 25 laptops, and then also a student or a teacher laptop with like all the examples, the PDFs for the curriculum.
Yeah.
And then there's also a router that we take. So we make sure we go with 2 people necessarily to do one of these classes, because what's involved with the pre-class setup is we got to make sure all of the laptops connect to that one Wi-Fi router and are joined onto this network, such that at the end of the class, the kid, what they can do is, here's my file. I've saved it to your shared folder that you've prepared for me on the desktop. And I have a folder that I show up on the projector, basically urging students the urgency of finish your project by the end of the class, get your file loaded up there. So I collect a file from each student, each class. It's a 7-week class. And the first class we go over basically like what the 3D modeling software is, how to save the project, and we don't expect them to save a file the first class. We just show them the process. And then the second class we have them save a file, and it's usually a basic project. So it's like a name tag. So it's here's a flat drawing, extrude it. Here's the text tool, put the text there. Here's a circle, draw a hole through it, and you have like a backpack name tag or like something for your keychain or whatever. So that's like project number 1. And then each successive week, we introduce a new tool in the 3D modeling software. So like one class, they do like a necklace. So they learn how to do the circular pattern tool in that exercise. So there's 7 weeks, 6 weeks of those classes. The students produce a file, and the instructor will come back to the warehouse and they'll be like, here's my 30 kids files. I need them for my next week when I go there Tuesday again the next week. And I'll be like, okay. So we'll have like basically like 10 of those classes at once, in a given week. We have like we have essentially 30 client sites where we do this after school project, this stuff. But then our
after school.
Yeah, that's our one income, and our other income is STEM for schools, where we have instructors at the school during the school day, and we bring the assets to the school there. And so we have 9 of those sites. But
see.
yeah, there's a lot of assets. There's a lot of, we try to get a lot of part-time instructors, start them off on those after-school sites first, and then get them to the STEM for school sites during the day if they work out.
Yeah, I'm a full-time teacher as well.
Yeah,
I teach at Garden Grove High School, and I'm more media, graphic design, and video production. But I've been getting to 3D printing, and you know, it's been really fun. And Eric on that group, Eric and Andy Wolf, those guys are they're my department actually, and so we've been all getting into this and really fun. But man, 3D printing is a pain in the butt. Oh my gosh.
Oh yeah, huh?
So much to it. It's so like, it's so not mainstream yet, right?
Oh yeah, no, like the biggest thing you can do to like have the eliminate the most amount of problems is to not worry about slicing ever, right? If you can avoid it, like trust. Hey, look, this profile, this looks good. Or maybe go on a forum and be like, hey, does somebody have a profile for this kind of thing I'm trying? And someone will offer you one. Right. Save it. Maybe like have a folder on your desktop of profiles you want to try. But definitely don't like get in there and like start adjusting settings and like extrusion multipliers and all this. Well, don't
there's too many variables. Oh my gosh.
Yeah.
It's just too confusing, man. It's like it's just like building a car or something.
Yeah, so ideally the same G code, right, should operate the same way on all your printers. So definitely check that Z coupling. That's a huge thing. Yeah, absolutely.
Just make sure it's tight on both of them.
On both the set screws, right.
Right. Okay, I'll try that. And then now the carriage itself, I feel like this, I don't want to touch it right now, but look at this one right here, okay? Oh my gosh, you're right. So this carriage is not very loose, but on the other one, it's a lot more. When I go like this, this thing moves up and down quite a bit on the other one. Like when I go like this one doesn't move that much, but that one, if I go like this, it's quite flexible.
Oh yeah.
Could that be, you think, the Z coupling?
Yeah, you're lifting the whole thing off the Z coupling. There.
Huh. Okay. But you know what?
That Z coupling is definitely your prime suspect here on this pink machine.
Okay. Sounds good. Well, I really appreciate your time, Blake.
Sure, no problem.
Thank you so much.
Yeah, if you like to check out my work, you can see the hashtags that I post my work under.
Okay, I'll check it out.
Yeah.
Thank you so much. I really appreciate it, man. Thank you for all your time. Thank you, Blake. Appreciate it.
Have a good night.
Bye.
Bye.